Now that we have this, we know that these will match. So we have 0.02. They don't need to match though. It's just something that I want to make sure that happened so that we have a bit more consistency between the two VDBs that we're going to be using. This is just a visualizer, so I'm going to kind of give it a different color. Now, how are we going to be creating those revolve velocity vectors? So we're going to use a volume VOP, and the volume VOP will take in this volume, and it will take the VDB surface, the SCF surface VDB from that side. When we create here a VDB from polygons, it is a good idea to give it some more exterior band polygons and fill interior. Let's give it 20, should be enough. And yeah, this just means that if you hit W, I think this is the easiest way. If you hit W, you'll notice that you do see a lot more around the object than if you just have the 3. Okay, this is much more contained. It means that the VDB is actually considering a bigger area around the object rather than just having it so close to the surface. So maybe 10 is enough. Okay, into the volume VOP. And the magic is going to be coming from curl noise. We've used curl noise before. Same way, so we're going to be using a vector to vector 4 to grab position and also make sure that this is affected by time. So now we have this vector 4 that we can add here, and now this is going to be evolving with time. We're going to be bind exports velocity. So let's change this to vel, and let's change the flow to vector, and this should work. So now we have velocity, this we do not need. And now that we have velocity, we can just see how this looks. We're gonna compare these two. So we have this. One thing I want to make sure we do here is we need to figure out the range of this. So on the options that we have here, let me kind of bring this down. The options that we have here is detect range. If we disable this, we'll have to adjust the maximum ourselves. And the goal is for us to kind of figure out at which point, after which point it starts showing some red, which means it's going to be capped at 1. I think 3 is a good number. Okay, so if you go to 4, we'll lose most of the red. If you go to 2, we have too much red. So 3 seems like we're covering the whole range. Now let's have a look at what we have on this one. Let's make a copy and apply the same thing here. As you can see, we need to adjust the frequency of our curl noise. It has very little to do with what we have on the other one. So that's the first thing. And the way I'm going to do that is I'm just going to go inside and drag this here so that I can actually edit these parameters without having to expose anything on the volume VOP. I could do that as well. That would be fine, but I think this is good enough. We're not going to be continuously adjusting, so we just need to make this adjustment. So for the frequency, we need it to be a lot higher. So let's go 4 by 4. The scale is immediately better. It's much more proximate to the type of detail that we have here. We also can use some roughness, 0.6. It's a bit similar to granularity, I would say. Now, definitely the intensity, we need to have this matching the maximum 3. So we need to kind of reduce the amplitude. Let's bring it 0.5. So we still have a lot more red than we had on this one with the same maximum value. So this is still too much. Let's try 0.3. And this is definitely more on point. Okay. Probably the frequency could be improved, might be a bit too small. So let's give it a try with 3, 3, and 3. Now we've gone a bit too far, so I don't have to wait for it to update every time I change a parameter. What I'm going to do is Here on the auto update, I'm going to switch to manual, and I'm going to put this at 3.5, 3.5, 3.5, and then switch to auto update. Yeah, this seems better. We may be able to even increase the amplitude a bit. Maybe a bit more. Okay, close enough. Now, going back to inside, the idea is for us to create a curl noise. We have the basic curl noise, but we actually want the curl noise to react to the surface of the object. And for that, we have this little input here, SDF, and we're going to be grabbing the second input of our VOP, and you'll see something magical happening around the character. Okay, now you can see that around the character, we have some vectors that will revolve around the shape of the character, which is awesome. The parameters that are relevant for this effect are going to be the surface effect radius and distance to surface. We're going to be, I've tried different values. These are too high, so I'm going to bring this to 0.1, and we'll see what happens. Not much. 0.2. These are kind of acting in together. Let's try to change this back to 1, to see if this is doing anything. I don't see much difference at all, so yeah, just gonna keep it at 1. It's fine. Surface effect radius, and I think this value is good enough. Let's give it a try. Let's see how this reacts to us having more voxels active around the VDB, if that makes any difference. Let's increase this to 20. Slight change, pretty much nothing. So let's give it a 10. Should be faster to compute. Now that we have that, of all this curl noise that we have here, what we actually want is just the part around the character. How can we isolate that? That's pretty easy. So what I'll do is I'll create a copy of this, and this won't have any input on the SCF, which means that I can then subtract. You'll notice by the colors that these are much lower values than we have around the character. Around the character, we have higher speeds. So what I'm going to do is subtract that. Subtract the curl noise without that from the curl noise with the SDF. And when we do that, we pretty much get just the part that we're interested in. Okay? How cool is that? Great. So now that we have this, we're going to be grabbing, if you remember, we actually already have some velocity coming in inside input 1. So that's all we need to grab. So let's create a bind. This bind is going to be called val. I won't have any vote in the matter because it's already set up by this bind. And what we'll do is we'll add this magical revolving velocity to the previous velocity vectors we had. Okay, so now we have this. We have essentially the same we had before. Okay, the same we were using on the previous simulations, but now we have this one with some extra revolving motion around the character. Okay, let's give this a try. So what happens here, in my opinion, is that the values here are just too high. I want to scale down the revolving part of these vectors, so they're not as exaggerated as they are right now, and that's so easy to do. So let's just do it. Let's multiply constant, and let's figure out which value we want to apply here. So multiply, I don't know, 0.5. Will that be enough? I think that's enough. So We should have some red. These should be stronger, but we don't need them to be all red. So I think 0.5 might be a good number for now. And let's give this a try. And also, same thing, I'm gonna process this same as before. I'm gonna make sure that we have just applying the primitive here. Just make sure that as we process through the volume VOP, I want to make sure that before we save, everything is converted to 16-bit. And I'll just copy this one as well. And as I copy this one, I'll call this one val vol revolve. And that should be it. We have the same path, and I'm going to be caching this out. I'm going to press just file save, always good. Save to disk in background, also not a simulation. Save to disk in background, and we'll wait for it and see how it goes. So here it is. We now have that new advection volume in place. And you can see the character going through those velocity vectors. Okay. In fact, this could actually be considered a 2.0 version of our original velocity volume. We could even consider testing the other simulations that we've been doing so far with this velocity volume instead of the previous one. That's something we can postpone for later, but for now we have this, and this is really important for the revolve effect that I want to be creating next. So I'll just finish up with a null and call this out val vol revolve. Change colors. Let's put these in yellow. So these are outputs, and that's it. Let's move on to the next lesson.